Good morning, everybody. Thanks very much for joining this webinar. I hope you find something of value in it. So this is kind of the introduction to Neo4j, so that you'll find that we're running a series of webinars of increasing depth and covering more specialized subjects, including some demonstrations. I hope you can join for all of those. But today we're just going to look at the entry stage, if you like, to your journey into Neo4j by describing what the product is, how people use it, and how it's put together. So who we are, what it is. So Neo4j is the company behind the Neo4j Graph platform. So the Neo4j Graph platform is what we're going to talk about this morning. But in essence, it's a database and some surrounding facilities. And as a database, you'll be thinking of other types of database that you've worked with. And this is a particular one that's designed, as it says here, to store, reveal, and query relationships. So it is about data. Obviously, it's about data, but the real emphasis is on relationships, data in context, data connected to other contexts. So we're going to talk a lot about that. But essentially, as it says here, what we're going to use it for is to traverse and analyze connected data to any level of depth. So these can be unbounded queries going as deep as you need to into the connections between the data. One other point, it's a real-time ACID database. You can read and write in real time, and as you read and write, the answers that you get to queries will naturally change. So just a few small points from the bottom on the left. It's designed, as it says right at the bottom, for graph adoption. It's easy to use, and if you're not already using it, we do recommend that you go to our website and do the download. It comes with lots of helpful guides and should be very easy to use. If you're in an environment where you're with a locked down computer and you can't download software, there is a set of sandboxes on our website as well. So I hope right after this presentation, you'll go and start playing with Neo4j yourselves. It's designed to be easy to use. It's designed to make you productive, to make your developers productive. So I won't talk through the rest of those points at the moment because we'll cover those in the rest of the presentation. And we'll also look at the diagram on the right. But these are the main elements that come with Neo4j in what we call the graph platform. So Neo4j is the innovator in graph databases. So we developed a model called the labeled property graph. We introduced that as an open source product in 2010. And when we did that, we were absolutely alone in this market. Since then, well, our success and changes in the world have led to other players entering the market, but we've now got 200 developers working on Neo4j, which is by far and away the largest number of people working on a graph database anywhere. I won't talk through all these points, but if you look at the end of the graph, you can see that the rate of innovation is not just being maintained, it's actually increasing. And some of the significant things that we're doing now, which keep us well ahead of the competition, are listed in some of those points on the right. So you'll see right at the bottom, Neo4j Cloud. We're just about to launch a database as a service offering. If you're interested in that, you can contact us and we can give you an endpoint that you can use for databases to use Neo4j without having to install anything yourselves. Morpheus, you'll see there, is our big data integrator, allowing you to use Apache Spark with Neo4j. If you look above that, you'll see the GQL manifesto. So Neo4j is leading the effort to get graph thinking included into ANSI standards in the same way that SQL is an ANSI standard. So that makes the whole industry better for everybody and protects the investment of people who've invested in Neo4j. I won't talk through the rest of these points, but hopefully you'll see that there is a lot of innovation going on in Neo4j. So I said I'd look at the graph platform in a bit more detail. So first thing to say is it's a database. Right in the center, you can see the blue database. To the left, you'll see it's a transactional database, so it's ACID, it understands rollback, it's a guaranteed place to store your data. Looking to the right, you'll see it's also an analytic database. So it's designed to tell you things that are true of, to help you understand things that are true of a large population. So the most famous graph algorithm is probably PageRank, which was the algorithm that propelled Google to enormous fame and wealth. That's a graph algorithm. You can use Neo4j for running PageRank. In fact, it's probably the fastest environment for running that PageRank algorithm. But that's just one of a class of algorithms that you can use to characterize the subpopulations, the important players, the other big things that are characteristic of any population. So Neo4j is both a transactional database and an analytical database. Now looking around the circle or around the square, at the top you can see drivers and APIs. So Neo4j is designed to be a backend to an online service. Typical transaction response times are in the milliseconds and very high volumes. So that's you can do that from your own development environment, Java or .NET or whatever, and calling into an API on top of Neo4j. Looking over to the right, it's not just about online transactions. The data that's in there is interesting, and you may want to explore it and to visualize it. So we have lots of users who are using Neo4j for discovering, for examining fraud situations, or for exploring data lineage in their database. And those are visual use cases. So we have visualization tools to support them. Over to the right, you'll see the analytical tooling. So as well as the algorithms that you can run within Neo4j, such as PageRank and so on, we recognize there's a big world out there. So you can talk to Neo4j through R and Python, and we can interact very closely with Spark and other big data platforms. At the bottom, Neo4j obviously has to exist in your data environment. So we need to be able to get data and push data to other applications. And Neo4j has a rich ETL suite. And then finally, you'll need to run it in production. So it's designed to be operated in secure production environments with all the monitoring and security features that you'll need if you're an enterprise type of user. Okay, so looking at the main components of it, the first one is probably the most important, the thing that makes Neo4j special. Index-free adjacency. Do I like that term? I'm not sure. But what it means is that as opposed to a relational database where you need to use indexes and key lookups to traverse from one table to another, you don't need to do that with Neo4j because you have direct connections. And that's a really important thing about Neo4j. So if you think about a relational database, your SQL statements will often include join statements. So joins are the way you traverse from one entity type to another entity type, or from one table to another table. And what that's doing is, at the time that you read the data, you're doing a calculation. You're loading lots of data into memory. You're doing a calculation and finding out how to join one table to another to get a result set. With Neo4j, you don't have to do that because the connection is stored at the time the data is written. So we store that data we store that relationship on the disk, if you like, as a pointer, so that you don't have to calculate it every time you want to read it. So there's a marginal write cost, if you like, on a graph database. You have to write a relationship as well as writing the row, but the benefit comes at read time. And with most applications, you read far more frequently than you write. So we get a payback in almost every use case of much faster performance. And one further thing on this point, one of the key things about Neo4j is that it's what we call a native graph database, which means that way of connecting data is right through the stack, right to storage on disk or SSD or whatever. So you're not being asked to have a graph view on some other model. It's a graph from top to bottom, and that gives us this great advantage of index-free adjacency. Okay, the ACID Foundation, so it's an ACID database, so it's designed for transactional operations. It's a full stack tool. What does that mean? It means it's resilient, high availability. If you drill into it, not only do we have high availability, we understand data centers, so you can have a replicated core of guaranteed correct machines in distributed data centers. We also support what we call read replicas for running long-running analytical jobs and things like that, which don't interfere with the transactional load. Moving down to the bottom on the left, it's designed to make life very, very easy for developers. Developers inherently understand, once they've started looking at it, they suddenly find that graphs are a very easy and convenient way of looking at things. Finally, it's a declarative. We use a declarative language. So as with other advanced databases, the database uses the knowledge about the way in which the data is organized on disk to optimize your queries, saving you the effort of needing to understand the details. And finally, it's got this analytics engine, which means it's very powerful for the emerging class of AI and machine learning and natural language type of language of applications. Okay, let's just drill back and look at what a graph database is. So a graph database is a database that implements the graph model, and the graph model has nothing to do with graphics and with pie charts and histograms. The graph model is to do with nodes and relationships, or vertices and edges, some people call them. And a node is just a data-bearing item. It's what we call schema optional, so you can store as many properties as you like with any item, and that you don't have to have the same data stored with each one. And that you can have so we're looking here at the relationships between the nodes. So there can be multiple relationships. The relationships have got directions which you can use if you want to. If the relationships are irrelevant to you, then you can just ignore them. And each relationship can also have properties, which is an immense convenience compared to other types of data storage. So looking at other databases, Neo4j is kind of, it's in the NoSQL class, in the sense that you don't use the SQL language to access it. But that's a confusing way of looking at it, because actually Neo4j is far more normalized than a relational database. You don't need to go through a denormalization stage to get high performance. Neo4j is the most clearly logically expressed possible way of expressing your data in a database. Everything, there's no duplication, there's no redundancy. Everything is stored on disk exactly as you'd have it in your conceptual model. So it's even more normalized. It's more likely to be normalized on the disk than with any relational database, and that gives you great advantages. And I'll just draw attention to one of them, which is that with Neo4j, you can say, okay, I've got a node A and a node B. Please find me a path between them. So you think about that with a relational database, you might have 10 different key fields which give you access to different join tables, which might provide the links between them. And you'd have to program your way through using all of those. With Neo4j, you don't do that. You just ask the database a simple question: how is A connected to B? And the database will tell you. So it's a very, very declarative, clean, and a simple interface. So that's enough about that for the moment. What sort of things are people using it for? Well, I'll use this picture, which is kind of a typical enterprise picture. to draw attention to some of the ways in which people are using it. So what we're looking at here in the center is some sort of data lake, where you've got different users accessing the sort of central repository, or the central store of all the data. And you can see some of the ways in which Neo4j it works in this sort of context. So over the extreme left, everything from cybersecurity. So that's often using Neo4j as some sort of configuration management database, and keeping track of all sorts of aspects of assets, but also of imported information about threats, looking also within the CMDB at different levels of service, so not just looking at the physical level, but also the business layers on top of it, user layers and service layers. So that's a typical, very physical use case. Towards the bottom, immediately below the data lake, we've got metadata. So Neo4j, because of its incredibly flexible data structure, is really great for data lineage, or for joining together data that's come from numerous data sources, and enabling use cases like Customer 360 or Total Customer View. Looking at the top, on the right, you can use it for data analysts. We've already talked about the population analytics things that we could be doing, such as PageRank, but it's also used for people who are looking for fraud, looking for crime and so on, using Neo4j to analyze interactions between people. So I've mentioned that we invented this 10 years ago, 7 years ago, or went public with it 7 years ago. Since then, there's been a massive amount of interest generated in graph databases, and you'll see graph databases coming from most of the established players. But as Forrester said last year, we absolutely dominate the market, and the market is very big and is growing. So they say nearly 70% of enterprises will be using graph databases by the end of this year. Gartner did a bit more detailed analysis, and when they asked people what they were using Neo4j for, they said they're using it for innovation. So people who are trying to move to digital, people who are trying to do new things, are using Neo4j for those new projects. And Frost and Sullivan had this insight, which I think is quite good, that actually the data, analyzing connected data, is really a new way of looking at the world, and you need specialist tools for doing that. So let's just look at that in a bit more detail. So everybody's familiar with these sort of figures, saying that the data is exploding, and you know, we don't need to look very far. You know, you may have a heart monitor on your sleeve. You've certainly got a phone somewhere on your desk or in your pocket. All of these things you weren't conceived of at the time that people were designing relational databases. And the thing about them is they're all connected. They're connected to in a myriad ways. The number of connections that, the number of logical connections between the applications on your phone and internet bodies would frighten you if you realized how connected it is. So to make this concrete, it's a bit too painful to look at the one on the right, which used to have some footballers on it. So let's look at the one on the left. So when we're talking about connectedness, we're not just interested in looking at people and their position in organizational hierarchies. We're interested in their social interactions, their Twitter accounts, their LinkedIn. You know, the number of ways in which I communicate with my colleagues and my family has just exploded. You know, everything from WhatsApp and SMS and Slack and email. It just goes on and on and on. more and more different connections between me and the people I'm interacting with. And it's the same for everybody. And it's not just me being connected in lots of ways. You know, my home is now connected, my TV is connected to my router and all the rest of it. All of these things are just proliferating networks, and there's value in understanding the connections between things. And some of the value that comes out of that it has, you can see, you can characterize it as some really big changes in the economy and in the social infrastructure. So being able to look at things in terms of connection is driving, for example, drug discovery. So we've got lots of people who are using Neo4j for analyzing medicines and the human genome and discovering new medicines that are going to be effective. Product personalization, so recommendations and things like that. These concepts really didn't exist 10 years ago, and now they're incredibly valuable. And the secret, in fact, it's true with medicine as well, but the secret with successful marketing is personalization, making sure you're delivering the right message or the right drug to the appropriate person. So these are big trends, and over on the right, AI and machine learning. So we'll talk about a little bit of one example with Neo4j in that context in a minute. The main use cases for Neo4j: recommendations, fraud detection, IT network operations. We've got a lot of users in telco, master data management, customer 360 type of things, and knowledge graph and analyzing information to answer questions better and to drive AI, and also identity and access management. So there are some pretty good company names or examples of each of these. I won't talk through them, but let's just focus on three very big customers. So what we're talking about here, for example, this retailer on the left used Neo4j because they had the previous year failed to be able to cope with demand on Cyber Monday. So it had cost them an enormous amount of lost business. Neo4j is under enormous load, but as you can see, it's executing queries very fast. And we actually, the customer there was previously using IBM e-commerce server and replaced it with Neo4j for doing product recommendations. The second example is a hotel pricing, so it's working out real-time room prices. And the thing to draw your attention to there is that this company is doing 10 times the volume on half the hardware. So that's a 20-fold improvement in performance. And if you're renting capacity from Amazon or renting capacity from Azure, this is a direct bottom line saving in being able to do things more efficiently. The example on the right is a German postal parcel delivery service, and the tagline for that is that Neo4j saves Christmas. We implemented this system just before Christmas for doing parcel routing in a way that allowed them to do real-time routing as roads got congested or flights got delayed, to deliver thousands of parcels per minute. Okay, another example, probably the thing Neo4j is best known for is the Panama and Paradise Papers stories. So this is using a database. The journalists who received this leaked data used Neo4j for making sense of it, for looking at the different connections between the government players and the investments that people had and the private individuals. I won't talk through this in detail, but the Prime Minister of Pakistan is on trial at this moment as a result of information that was exposed by the analysis that the ICIJ did using Neo4j. The Prime Minister of Iceland, as you probably remember, resigned almost immediately after the initial leak. I said I'd talk about an AI example. So if you use from Facebook Messenger. You can order things on eBay using the eBay shop bot. That's got Neo4j behind it. Neo4j is being used to store the catalog of products on that. So I'm not going to talk about that in too much detail, but there's a lovely video of it on our website, or you can just go direct to eBay Shopbot. Thomson Reuters have a eBay-based tool, a Neo4j-based tool for portfolio managers. So what these people are doing is looking at interconnections between companies and news stories. So a good example is when the Volkswagen scandal was exposed. That was bad news for Volkswagen, obviously, but it was bad news for any other company that sourced their exhaust control from the same company as Volkswagen did. And if you know who those companies are, and you're an investment analyst, you can short their products, or their shares rather, and you can buy into the ones that have got a distinct supply chain that's not connected to the potential taint. So this is the sort of thing that Thomson Reuters are doing all the time, using Neo4j for helping them to drive these decisions. And finally, this is an Internet of Things example. So the Comcast use Neo4j to monitor all the things that are connected to a customer's router, so that they can understand better what the usage is, and who's coming into and out of a house because their phones get connected and so on. So it's an extremely powerful tool that allows you as a householder to really understand how the people in your house are using their equipment in your house, and it's just possible. It has some marketing benefits as well that Comcast uses to help its marketers or its marketing customers to understand better. So sorry, it's been a bit of a romp, but I'll just end with a slide of a few of the major companies that are using Neo4j, and I hope we've got just a couple of minutes of questions, Angelica.
Yeah, absolutely. Okay, so to start us off, do you typically see people using Neo4j on its own, or does it work well with other databases as well?
So yes, we startups often use Neo4j on its own. Enterprise customers never use Neo4j on its own. So it's got very good import and export interaction capabilities with other databases. Very common to see Neo4j being kept in sync with other databases, so that you can use your traditional Oracle or SQL Server database for doing whatever they do, but then do rapid analysis within Neo4j. So yeah, both those use cases occur, and both of them are very well supported.
Okay, and on that point, how easy is it to transition data, relationships, etc., from a SQL Server database over to Neo4j? And what's kind of like the best migration path to import a large volume of data to Neo4j?
So there are a couple of tools that we've got for doing that. So you can do it completely automatically. You can just point Neo4j at your SQL Server database and create a schema in Neo4j and import the data. Obviously, you won't be taking advantage of the graph model if you do that. So you may want to make some model changes, and that's what our ETL tooling helps you to do. And actually, there's a lot of initiative happening on that, and we're working with some of the biggest ETL and data virtualization vendors to get even more power out of that.
Okay, great. And sorry, so can you elaborate a little bit on using Neo4j to detect cyber attacks in a network, perhaps around fraud detection? Is that a use case that you see often?
It is a use case we see quite often. There's a really interesting set of videos that have been put together by one of the American national security government agencies about using Neo4j. And what they do is they look at the real-time updates to threat databases. And the threat database gives you information about new bits of malware and which systems they apply to, which version, which software versions, which hardware versions, and so on. And what they do is use Neo4j as a CMDB, so they can immediately see what the vulnerabilities are. And there are actually a few other ways in which you can use Neo4j in a cyber context. We're going to send out an email with a copy of this video. So if you're interested, reply to that, and we can maybe have a more in-depth conversation.
Yes, definitely. I'll provide you all with a bit of contact information as well. If you do have some more specific questions and want to get in contact, please do that via the follow-up email. So I think we're just about out of time. I'll add in one more question. Just we have a few around the types of nodes that you can do essentially. So a lot of the examples are showing text data. Is it possible to manage media data like images, videos, or audio files?
So the typical data types we support are the Java data types, including arrays. We've also got date types and location data types. You can store blobs, but we wouldn't recommend it. Neo4j tends to be used for kind of useful structural information rather than for bulk storage. So I guess typically you'd store a URI or something to help you to access it. Very common actually to store foreign keys for other databases in Neo4j, so you can take advantage of Neo4j to work out which record you want from another database, but then actually retrieve the data from somewhere else. So yeah, probably wouldn't be storing big audio files or big videos.
Okay, makes sense. All right, so I think we're just about out of time. So thank you so much and enjoy the rest of your day.